On a clear winter's day, a group of Russian designers and test pilots are reunited with an old friend. The aircraft that once promised to make Russia world leaders in supersonic travel sits quietly like a ghost from the past. But it's in looking to the future that a team of Russian and American scientists have awakened the mighty Tu-144. In an unlikely agreement between NASA, Boeing, and the Tupolev Design Bureau, a Tu-144 was taken out of mothballs. Because of its size and wing shape, the Russian plane makes a more suitable candidate than the Concorde. Powerful new engines were borrowed from a long-range blackjack bomber, and Russia's supersonic giant was brought back to life. Next, the passenger compartment was gutted, clearing the way for stacks of flight test equipment. The flight test program began in 1997. The modified aircraft was given the official designation Tu-144LL. Flight experiments were divided into 6 phases over the course of 32 flights. Sitting in the foreground is Tu-144 crew commander Sergei Borisov. Sergei is an unlikely choice to fly such a big plane. He used to fly fighters in the Red Air Force. Now he's at the forefront of a program that promises to pave the way for the next generation of supersonic travel. As the powerful blackjack engines pin the flight crew to the back of their seats, it's clear why the Russians chose a fighter pilot to lead the mission.
I'd say the Tu-144 is eager to take to the sky. During takeoff, I only need to pull the stick back 2.5 inches.
The front gear leaves the ground at 220 miles an hour. The main gear liftoff at 250. In a plane with this kind of acceleration, there's little room for error.
You have to be very careful not to exceed 250 miles per hour on takeoff, because at this speed, the canards can break off. Also, the nose can break off because it's pointed downward 12 degrees.
The droop nose makes for a bumpy ride. Unsettled air rocks the plane, and the roar of the engines makes it impossible to talk without an intercom. As the nose straightens, Sergei and his crew disappear into the clouds. Within minutes, the Tu-144 climbs past 30,000 feet. Now the tone in the cockpit begins to change. Approaching the sound barrier, the chaotic sensation of takeoff settles into a peaceful ride.
When the nose straightens, everything quiets down. I don't hear the roar of the engines, and during the flight, it is remarkably quiet. When it reaches supersonic speeds, I can't feel anything. It's very smooth.
From the inside, the ride may be smooth, but what goes on outside tells a different story. Sensors attached to the wing to measure heat and airflow have been ripped off, taking the paint with them. Speeds approaching 1,600 miles per hour have taken a toll. The scars of flight serve to remind how difficult it is to build a passenger plane made to fly this fast every day.
During the first flight, the paint already began to flake off. We've started to repaint the plane, but because of the cold weather, we haven't had enough time. As you can see, even the NASA emblem is flaking off. Tupolev as well. We'll sort it out.
Engineers striving to create a supersonic transport have a long line of hurdles standing in their way. Every time a problem is solved, another creeps up behind it. Shaping the wing for high speeds makes it less stable during takeoff and landing. Building engines quieter also makes them heavier, and so on. But many believe that the desire to get places in half the time will overcome every challenge.